Welcome to this explainer. Today, we're diving into what is, honestly, the ultimate HVAC superpower, literally predicting the future of your mechanical equipment. We're talking about a massive shift in how we manage facilities. Instead of constantly being caught off guard, you're always one step ahead.
So, think about it. What if you could actually predict when an HVAC system, or really any crucial mechanical equipment, is going to fail before it actually breaks down? I mean, imagine the impact that would have on your business. We are talking about slashing unexpected downtime, drastically lowering repair costs, and getting way more life out of your equipment just by knowing exactly when a breakdown is coming. And hey, this isn't science fiction anymore. It's the reality of modern facilities management.
All right, Section 1, the evolution of maintenance.
To really get why this is such a game changer, we have to look at how things have traditionally been done, right? For the longest time, the industry's been stuck in one of two modes. On one hand, you have the absolute chaos of reactive maintenance. You know the drill, fix it when it breaks. You literally just wait for a component to fail, the whole system goes down, alarms are blaring, and you're scrambling to get it back online. Super stressful. Then, on the other hand, you've got preventive maintenance. Now, fix it on a schedule definitely sounds better, but when you really think about it, it's basically a blind routine. You're out there swapping belts and changing fluids based on a calendar, whether the machine actually needs it or not. So you're either throwing money away on unnecessary maintenance, or even worse, you still end up missing a failure because it happened between those scheduled visits.
Well, the solution to all that chaos is predictive maintenance. This completely rises above those old, clunky methods because it relies on reality, not a calendar and definitely not a catastrophic failure. It's just smarter. It's all about monitoring your equipment's real-time condition and predicting when maintenance is actually needed based on actual wear and performance. So you're taking the guesswork completely out of the equation.
Moving on to Section 2, the AI advantage.
So how do we actually pull this off? Well, artificial intelligence is the ultimate amplifier here. Think about a modern MEP system. It is constantly spitting out massive amounts of data. We're talking tiny fluctuations in temperature, really subtle changes in vibration, pressure shifts, and energy spikes. Now, a human being obviously can't sit there and monitor all those data points across dozens of machines at the exact same time. But AI absolutely can. It instantly processes all that real-time equipment data across all those vital metrics, and it does it without breaking a sweat.
And here is where the real magic happens. By acting as this tireless pattern recognition engine, AI can spot the tiny early warning signs of a failure way before a human technician would ever notice them. Let's say a fan motor's vibration signature changes just a tiny bit, right? And that happens alongside a half-degree bump in operating temperature. To a human doing a routine walkthrough, looks totally fine. But to the AI, that's a glaring red flag that a bearing is going to fail in exactly 3 weeks. It catches what we just literally cannot catch.
Let's look at Section 3, the cost of downtime. Let's ground this in reality for a second. Because in HVAC, refrigeration, and MEP, unexpected downtime isn't just a headache. It's not just expensive, though believe me, it is for sure. It can actually be dangerous. Think about critical facilities that absolutely cannot afford to lose climate control. In a hospital, a failure can literally compromise patient safety. Imagine a crucial surgery getting halted because the OR's HVAC system just suddenly quits. Or in a data center, a cooling failure there can cause catastrophic server meltdowns and massive data loss in a matter of minutes. And in a manufacturing plant, losing a mechanical system can shut down an entire production line. Get this, unplanned downtime costs industrial manufacturers an estimated $50 billion a year. $50 billion! That breaks down to thousands of dollars a minute. The stakes are just way too high for the old fix-it-when-it-breaks routine.
So what does this all mean for you? It means a massive return on investment. When you bring AI into the mix, you're directly attacking the biggest, most expensive pain points in facility management. You dramatically reduce that dangerous, unexpected downtime. You lower your overall maintenance costs because you're no longer swapping out perfectly good parts on the blind schedule. You extend the life of your equipment because machines aren't running themselves to death. And on top of all that, you improve system reliability and massively enhance safety and compliance across the board. It's pretty much a total win-win.
All right, Section 4, AI is for everyone.
Now, I know what you might be thinking. This sounds great, but it's probably just for massive aerospace corporations, right? Actually, no. We need to bust that myth right now. Today, predictive maintenance is highly accessible thanks to a whole new wave of modern tech tools. We've got incredibly affordable sensors that you can easily slap onto your existing equipment.
We've got cloud-based dashboards that are super intuitive, literally anyone can read them. And we have these awesome AI-as-a-service platforms that are built specifically for contractors, engineers, and facilities of all sizes. You really don't need a team of Silicon Valley data scientists on your payroll to make this work.
The tech has been completely democratized, so it really doesn't matter what your scale is. Whether you're a smaller operation managing a few commercial rooftop units, or you're overseeing an entire sprawling mechanical plant, predictive maintenance is totally within reach. The power of AI-driven maintenance is out there and readily available to you right now.
Which brings us to Section 5, 3 steps to start.
So how do you actually get this up and running without getting totally overwhelmed? It really just breaks down into a practical framework of 3 clear steps. Step 1, capture the right data. That means pulling info from those new affordable sensors or even from the smart equipment you already have. Step 2, analyze it. And don't worry, you aren't doing this manually. You let the software tools and AI platforms do the heavy lifting to spot the trends. And finally, step 3, act on those insights. When the AI taps you on the shoulder and says a part is degrading, you proactively schedule the maintenance before the actual failure happens. Capture, analyze, act. It's that simple.
Now, I will say, while those 3 steps sound super simple on paper, we gotta be realistic. Implementing a system in the real world does take some practical know-how. You can't just throw any random sensor onto a machine and expect magic to happen. You need to know how to pick the right sensors for your specific equipment, how to set up your dashboard so the info is actually clear and useful, and how to understand the trends the AI is pointing out. It's all about making sure you're looking at the exact right indicators for your unique setup.
And that's exactly why continuing to learn about this space is absolutely vital. To master these systems, you're going to want to build up some specific practical skills. You'll need to learn how to identify those vital data points, set up those AI dashboards, and remember, absolutely no coding required for that, and spot early failure indicators. You'll also want to learn how to apply all of this across HVAC, refrigeration, and broad MEP systems. But the good news is, there are some amazing resources, templates, and forecasting tools out there right now that will guide you through every single one of these steps. As we wrap up this explainer, I want to leave you with something to chew on. Take a hard look at your own operations. When you think about the evolution of your facilities and those constant battles with downtime and repair costs, have you started using AI in your maintenance program yet? If not, what could predicting the future actually do for your peace of mind and ultimately your bottom line? The tools are here. They're accessible. The future of maintenance has already arrived. The only question is, are you ready to use it?